the early years of the 20th century, scientists began to unlock the secrets of atomic energy, setting the stage for an unprecedented shift in global power dynamics. The discovery of nuclear fission opened the door to both immense scientific progress and devastating military applications. As tensions between world powers escalated during World War II, the race to harness this newfound power reached its peak. The first successful detonation of a nuclear weapon occurred on July 16, 1945, in the New Mexico desert as part of the Manhattan Project. Known as the Trinity Test, it was a pivotal moment that demonstrated the reality of atomic warfare and signaled the dawn of the nuclear age. This explosion, with an estimated yield of about 20 kilotons of TNT, was not only a scientific milestone but also a harbinger of the immense destructive power humanity had just unleashed. The Trinity Test laid the foundation for the subsequent use of atomic bombs in warfare, setting the stage for the events that would follow. It marked the beginning of an era where nuclear technology would shape global politics, military strategy, and scientific exploration in ways previously unimaginable. As we move forward in time, the next chapter will explore how this initial success led to the development of even more powerful weapons, with the first atomic bombs dropped on Japan being a direct consequence of the knowledge gained from the Trinity Test. The legacy of the Trinity Test is not just one of destruction but also of innovation. It sparked a global race for nuclear supremacy and initiated decades of research into both the peaceful and destructive applications of atomic energy. Just weeks after the Trinity Test, history was forever changed with the detonation of the first atomic bomb over the Japanese city of Hiroshima on August 6, 1945. The explosion, known as Little Boy, had a yield of approximately 15 kilotons of TNT and instantly obliterated much of the city's infrastructure, killing an estimated 70,000 people in its immediate aftermath. The devastation was not only physical but also psychological, leaving survivors with long-term health effects such as radiation sickness and cancer. The bombing marked a turning point in warfare, demonstrating the unprecedented scale of destruction that nuclear weapons could unleash on civilian populations. Hiroshima's fate became a symbol of the horrors of war and the ethical dilemmas surrounding the use of such powerful weapons. It also served as a catalyst for international efforts to control and limit the spread of nuclear arms, setting the stage for future discussions on disarmament and global security. The impact of Hiroshima extended far beyond Japan, influencing political decisions in the United States and other nations. The bombing underscored the need for a new approach to conflict resolution and led to increased scrutiny of nuclear technology's role in warfare. As we move forward, the next chapter will explore how this event influenced the development of even more powerful weapons, including the second atomic bomb dropped on Nagasaki just days later. On August 9, 1945, just 3 days after the bombing of Hiroshima, the United States dropped a second atomic bomb on the Japanese city of Nagasaki. Known as Fat Man, this weapon had an estimated yield of about 21 kilotons of TNT and caused widespread destruction, killing approximately 40,000 people instantly. The combined impact of the two bombings led to Japan's unconditional surrender, effectively ending World War II. However, the human cost was immense, with many survivors suffering from radiation-related illnesses for years afterward. The bombings also sparked global outrage and raised ethical questions about the use of such weapons in warfare. Nagasaki's destruction served as a stark reminder of the devastating power of nuclear weapons and their potential to reshape the world order. It contributed to the growing international movement for nuclear disarmament and influenced the development of treaties aimed at preventing the proliferation of atomic arms. The events in Hiroshima and Nagasaki not only marked the end of one war, but also set the stage for a new global conflict centered around nuclear technology. The next chapter will explore how these bombings led to the Cold War arms race and the development of even more powerful weapons. As we move forward, it becomes clear that the use of atomic bombs in warfare was just the beginning of a much larger narrative involving the control, proliferation, and eventual regulation of nuclear power on a global scale. In 1949, the Soviet Union successfully tested its first atomic bomb, marking a significant shift in the balance of power between the United States and the USSR. This test, known as First Lightning, had an estimated yield of about 20 kilotons of TNT and demonstrated that the West was no longer the sole possessor of nuclear weapons. The Soviet detonation triggered a rapid escalation in the arms race, with both superpowers investing heavily in nuclear research and development. This event also intensified global fears of nuclear war, as the world now faced the prospect of an all-out conflict involving atomic weapons on a massive scale. The Cold War era was defined by this constant threat of nuclear annihilation, with each side seeking to outmatch the other in terms of both quantity and quality of nuclear arsenal. The Soviet test not only solidified its status as a global superpower, but also set the stage for future developments in nuclear technology. As we move forward, the next chapter will explore how this arms race led to the development of even more powerful weapons, including hydrogen bombs, which represented a significant leap in destructive capability. The Soviet Union's first nuclear test was a turning point in history, signaling the beginning of an era where nuclear power would play a central role in shaping international relations and global security. In 1952, the United States successfully tested the first hydrogen bomb, known as Mike, which had an estimated yield of about 10 megatons of TNT, over 1,000 times more powerful than the atomic bombs dropped on Hiroshima and Nagasaki. This test demonstrated the potential for even greater destruction and marked a significant leap in nuclear technology. The hydrogen bomb was based on the principle of nuclear fusion, which allowed for an exponentially larger release of energy compared to fission-based weapons. Its development not only intensified the arms race but also raised new concerns about global security and the possibility of total annihilation. As both the United States and the Soviet Union raced to develop more powerful weapons, the world entered a period of heightened nuclear tension. The hydrogen bomb became a symbol of the Cold War's escalating threat, with each side seeking to maintain a strategic advantage through sheer force and technological superiority. The next chapter will explore how this new level of destructive power led to the development of even more advanced weapons, including thermonuclear devices that could potentially destroy entire cities in an instant. The hydrogen bomb represented a turning point in nuclear warfare, ushering in an era where the potential for global catastrophe was greater than ever before. In 1961, the Soviet Union conducted the largest nuclear explosion in history with the detonation of the Tsar Bomba, a hydrogen bomb with an estimated yield of about 50 megatons of TNT. This test was not only a demonstration of military might, but also a symbolic statement of the USSR's technological capabilities during the Cold War. The sheer scale of the Tsar Bomba's explosion was staggering, with its shock wave traveling thousands of miles and causing widespread environmental effects. The mushroom cloud reached an altitude of over 64 kilometers, making it one of the most visually striking events in nuclear history. Despite its immense power, the Tsar Bomba was never deployed as a weapon due to its sheer destructive potential and the political implications of such a massive explosion. Instead, it served as a warning to the world about the dangers of unchecked nuclear proliferation and the catastrophic consequences of an all-out nuclear war. The next chapter will explore how this event influenced global policies on nuclear disarmament and led to international efforts to limit the spread of nuclear weapons. The Tsar Bomba remains a powerful reminder of the destructive potential of nuclear technology and the need for responsible stewardship in its development and use. The 7 most powerful nuclear explosions ever recorded have left an indelible mark on history, shaping the course of world events and influencing international relations for decades. From the first atomic test to the Tsar Bomba, each event has contributed to a deeper understanding of both the potential and the dangers of nuclear power. These explosions not only demonstrated the immense destructive force of atomic weapons, but also highlighted the ethical and humanitarian consequences of their use. The lessons learned from these events have led to international treaties aimed at preventing the proliferation of nuclear arms and reducing the risk of global conflict. Today, as we continue to grapple with the legacy of these explosions, it is more important than ever to remain vigilant about the responsible use of nuclear technology. The history of these events serves as a powerful reminder of the need for diplomacy, cooperation, and a commitment to peace in an increasingly complex world. As we conclude this journey through the most powerful nuclear explosions in history, let us carry forward the lessons learned and work toward a future where such weapons are no longer a threat to humanity. The story of these explosions is not just one of destruction but also of resilience, innovation, and the enduring human spirit. It is a testament to our capacity for both great harm and great progress.